All right, now we're going to talk about when we have a square root function or a radical function with our linear function intersecting when they can be above or below. So again, like we normally do, put our square root in y1, linear in y2, graph it, bam. Hopefully deal with your window a little bit, but you should be able to see all four quadrants in this one. Pretty easy, obvious intersection. But the algebra for this one brings up some interesting features especially. So we need to find where these two intersect. So I'm going to set them equal to each other, as you can see right here. So the square root of b equals 6 minus b. To get rid of this, or I shouldn't say get rid of this, but to solve this, we're actually going to have to square both sides. So I'm going to square this side. And what you're going to see is I'm going to have to put this second side in parentheses and square it. This is where we usually make the most mistakes, or I see the most mistakes, knowing that this is going to be squared, but then we just say it's 6 squared minus b squared. That's pretty poor mathematics. So they drew it out for us also to say that when I square this side, it's b, but they just haven't expanded this side. Remember, if you need to, write it out. 6 minus b, multiply it again. Eventually, you get b equals 36 minus 12b plus b squared. I'll say the second common mistake I see is people start using the quadratic formula or factoring this. Well, guess what? If you start using the quadratic or factoring this, it's going to solve this, or it's just going to factor this. Because you have this b on the other side. You have to take care of it. Don't factor or use quadratic formula until you know it is equal to 0. So, one last step, we just have to subtract b from both sides. So we'll get 0 on the left and negative 13b on the right. So again, I would say, try this, factor this if you can. You can even try this whole problem before I get through it. Maybe stop the video and see if you can do it. But you see, you can tell the factors of 36. We get 9 and 4. So you can have a negative 9 and a negative 4, and that does get you to your negative 6. And how you write this doesn't matter if you say this is negative b plus 9 or negative b plus 4 or any version of this. It should be the correct factoring of this. So I get two b values, which is kind of interesting that I get b equals 9 or b equals 4. But as you can see over here, it only intersects once, and I didn't give you an x scale. I did that on purpose because maybe this is 4, maybe this is 9. So what we have to do is actually test one of those points, and I need to see the work of you actually testing those points. And what we're going to do is test it in this equation right here, because the value should make the left side equal to the right. So I'm going to just try my 9. That's the first one on the left. The square root of 9 equals 6 minus 9. So as you can see, the square root of 9, since we're just a positive here, doesn't have a negative, it's just 3. 6 minus 9 is negative 3. So actually that value doesn't work. So that's the one that we call an extraneous case. When we squared it, we're bringing in more solutions that are actually true in the original. And it's not a bad thing or anything, but we just needed it to get to our correct answer, which you can see if I do the square root of 4 equals 6 minus 4. Oh, 2 does equal 2. So this is the actual true intersection of that. So this little intersection, this x value right there, is 4. And that still goes on my number line. I might change this problem just a little bit from the original. Actually, I'll leave it just in case you're solving it and not watching the video. So I'm going to have an open dot at 4 for sure. But it wants to know when the square root of b is below or less than the linear. Now this one's a little tricky also, and this comes in with square roots. That this blue line right here, this square root line, is below this green line, definitely right here. Okay, all these x values are giving me a y value that's below the line. But something special about the square root, kind of where it starts, is that it starts at 0. And you have to think, well, can I take the square root of 0 and still get a y value? And that's totally true. The square root of 0 is 0. Now, why there's no function over here, no graph over here is we keep saying we can't take the square root of a negative, which we'll find out is actually false, but it doesn't give us a real value. So there's no graph over here, but it does start at 0. So if I plug that in, the square root of 0, I want to see if it truly is less than 6 minus 0. Well, you can see that 0 is less than 6. It's a true value, so it needs to be shaded. But it's a breaking point. That's where the function starts. So 0 gets a shaded dot or a closed dot. And then everywhere in between 0 and 4 works. So we actually get a shaded dot without there being an equal to sign, and we get an open dot because of this open dot here, that if I actually plug in 4, you kind of say here 2 is not less than 2. So just be careful of that with square root functions, and we can go symbols here, is that we would get 0 is, we'll go just less than or equal to, I'll put the equal to like that, x, and then less than 4. So hopefully you can figure out what I mean by that. 0 is less than or equal to, and then x. You normally put the line underneath. In fact, I'll just fix it quick and put a line underneath. Guess it's easy enough. There we are. And then interval notation wise, we're going to have a bracket, and then a 0, 2, 4, and then a parenthesis. So there you have it. There's our interval notation, symbols, and shading for this one. So be careful with square roots. That 0 does count. You know, you can try it in your head. If I flipped a sign, then I'm going to be all the way out here. Maybe 0 is not even involved in my inequality. So hopefully this gives you a help for the square roots and lines.